jokes now. So so I used my joke already, right? Can Jackson tell us what 1 over sine is? I didn't tell you that joke?
Cosecant.
Cosecant. If he said it was secant, that would be a case of mistaken identities. A case of mistaken identities. Okay, anyway, let's try to make math joke. So these are all called trig identities. You should know these the reciprocal identities. So, and I think most of you know these already, right? Those are called the reciprocal identities. Quotient identities, there's only 2 of them to know. Tan of u is sine over cosine, cotan is cosine over sine. And then we had the sine squared plus cosine squared equals 1, which comes out of the Pythagorean theorem. And then I just derived that one for you. 1 plus tan squared equals secant squared. Flip it around if you want. And 1 plus cotangent squared equals cosecant squared. The next one are called the cofunctions identities, which some of you messed up on the test that you took, because you said, I think it was rewrite cosine of pi over 2 minus x as something, and that's all you were supposed to do. If you wrote 1 over secant of pi minus 2, which a few of you did, I think
that's what I did.
I said that's okay, even though that wasn't what we were looking for. So you were what we were looking for is these cofunction identities. But you could write cosecant of pi over 2 minus. It just said rewrite in another
So
form.
did you count the one where I was like, put on the n plus 1 minus 1? I totally forgot to change the other thing.
N plus 1 minus 1?
I wrote the same thing down and then added 1 and then subtracted 1.
I don't know. I haven't looked at it. Okay. So anyway, that's what we were looking for, is that kind of thing. But if you wrote 1 over sine or something like that, I guess we'd have to accept that since we weren't specific, And then these are called the even odd identities. So sine is odd, meaning the sign of a negative value is the same as a negative sign of a positive value. And cosine is even, meaning that the cosine negative value is equal to the positive cosine of the positive value. So in other words, cosine of negative pi over 6 is the same as cosine of positive pi over 6, right? Whereas sine of negative pi over 6 is the same as negative sine of positive pi over 6. And that's what those things mean. All right, so then we use these identities to manipulate trigonometric equations, okay? So for instance, use identities. So now what we're going to do is use the trig identities without drawing a picture, okay? Use the trig identities to find for secant of u equals negative 3 over 2, negative 3 over 2, and tan of u is greater than 0, to find all six trig functions. Well, the remaining 5, right? Trig ratios, values, trig ratios, I guess is what they're looking for. Okay? So right away, we already know the first one, right? That's secant. So what does that mean that cosine of u would have to be? If secant is 1 over cosine, how do you find cosine? What's 1 over negative 3 over 2? That's equal to negative 2/3. All you have to do, that's right there called reciprocal. All you have to do is flip them upside down, right? And you got it, okay? So now I know cosine u, I know secant u, I want to find all the other ones. Well, the only way I can think, without drawing a unit circle, the only way I can think of relating them is using this thing, sine squared plus cosine squared equals 1. And so you can do that by, I'm going to go sine squared u plus cosine squared u equals 1. So now I'm going to use this identity over here to find sine, which you can do, right? And so, so all you do is you go sine squared u plus negative 2/3 squared equals 1, and then you solve that for u. And so then you get sine squared u plus what? What's negative 2/3 squared?
4 9.
4 9. Positive 4 9 equals 1. And then you subtract 4 9 from both sides, and you get sine squared u equals 1 minus 4 9. That's 9 ninths minus 4 ninths. 5 ninths? Yes? With me there? You should write this down. Some of you should write this down. Some of you don't have to write it down. But I don't know. Do you think you learned by writing things down? Well, maybe you should write things down. So then that means that sine of u is equal to plus or minus the square root of 5 over 9. So whenever you take a square root, and this can be rewritten as sine of u is equal to plus or minus the square root of 5 over the square root of 9. What's the square root of 9?
3.
3. So sine of u is equal to plus or minus the square root of 5 over 3. But up here it gives you a specific thing. It says tan u is greater than 0. So what does that tell you? Which quadrant am I in? If secant is negative and tangent is positive, which quadrant am I in?
The third.
Very good. Okay? You understand where, what's your name again? Savannah got that from? Okay, I'm just kidding. Okay? Momentary brain lapse. Yeah, I just, so, do you understand why you're in the third quadrant? Because tangent, you have negative, negative, right? So negative divided by a negative, because that sine over cosine is negative. So that third quadrant tangent is positive, and secant and cosine are negative. So that's why you choose the negative value here. So sine of u is equal to negative square root of 5 over 3. So if I know sine of u, now I can find cosecant of u. What's cosecant of u? How do I find it? It's a reciprocal of sine of u. So how do I do that? Come on. I just flip it over, okay? And I leave the negative sign up top, negative root of negative 3 over 5. And it's better to rationalize that denominator by multiplying by the square root of 5 over the square root of 5. And then you get equals negative 3 root of 5 over 5. What don't I have so far? What am I missing of my 6 trig function? Tan and cotan. So I know sine, I know cosine. What was cosine? Cosine was, I know sine, and I know cosine. So tan is equal to tan of u equals sine of u over cosine of u. And so then you're using that quotient identity now. And then we went back, we found sine of, we got no sine of u, and cosine was negative 2/3. So it's going to be sine of u, which is negative 5, negative square root of 5 over 3 over, what was it, negative 2/3? Negative 2/3. Negative 2/3. And you can flip and multiply, or you can know that these things go away. Did you know that? Those things go away. And you get positive square root of 3 over 2, don't you? Square root of 5. Oh, that should be square root of 5. I'm sorry. Thank you. Square root of 5. So you get positive square root of 5 over 2. And that means that that's a 5. Can you tell that's a 5? Nice. And then cotangent of u is the reciprocal of that, which is 2 over root of 5, which is equal to 2 root of 5 over 5 when I rationalize it. Okay, so that's how I use identities to find all my 6 trig ratios. Something like that, Kevin? Right? I don't know. Don't fall asleep. Hey, how about those? Go. So more using more trig identities. Are we recording now? There we go. So here we go. So they'll say simplify. Simplify. And a lot of this, you get very complicated trig equations, and a lot of times you need to simplify them before you solve them. So if you saw something like this, sine of x, cosine squared of x, minus sine of x, you might see something like this, or you probably will, where you have something on the right side, and you're going to want to try to simplify that before you do anything with it. So anyone have any ideas how to simplify that? How might I rewrite cosine squared of x with just sines? Come on. You got to know this. If sine squared x plus cosine squared x equals 1, right? What's cosine squared x equal to? One minus sine squared x, right? So a lot of times when you're solving trig equations, you want to write things all in terms of either just sines or just cosines. And that's easy to do when you have squares. So if you see a cosine squared, and you just have to do lots of these and get practice with them. So if you see a cosine squared, sometimes it's useful to write it as 1 minus sine squared x minus, was this minus or was it times? That was did I write down this problem right? I did. Okay. So that's minus sine of x. And then I can distribute through, and I get sine x minus sine cubed x. Sine cubed x? This isn't the way they do it in the book. Minus, so that should be a sine of x right there. Okay? Sine of x. And then I simplify this. What happens to these two sines x's? They go away. And so you get that this expression up here is equal to negative sine cubed of x. So if you had something like this is equal to 5 or I don't know, 1, oh, it couldn't be, it'd have to be less than 1. If this is like equal to 0.9, you can solve that trig equation by taking the cube root of both sides and then doing the inverse. We'll get to that part. Okay, but that's one way that you simplify. Okay? Okay, so anyway, they'll ask you to do things like factor things, because those come up a lot. So right now we're just learning some of the techniques that you use to solve trig equations. Secant squared of theta minus 1, and they'll say factor. Okay? Do you guys know how to do that?
No.
Just treat this as if it's x squared minus 1. Pretend it's x squared minus 1 instead of secant squared minus 1. How would I factor that? Right, very good, Henry. It's difference of squares, x minus 1 times x plus 1, like that. So secant squared minus 1 is equal to secant theta minus 1 times secant theta plus 1. So with a lot of things with these identities and stuff, just because they have trig functions in them, don't, it's just like they're x's, you know? It's just like, just pretend they're x's, and then they won't be as scary. Okay, got that? That's easy. Then there's another thing you might see where they'll say factor. And I'm just going through the examples in the book. I'm not being too innovative here, but you don't care, right? Cosecant squared x minus cotangent of x minus cotangent of x minus 3. And you say, I can't factor that. I have cosecant, I have x's and y's. It's like having x's and y. So what you have to think when you see something like this, where you have mixed terms or mixed trig functions, and they want you to factor it, you have to look at one of those identities. Do you see one of these identities up here on the board that I might be able to change a cosecant into from a cotangent or into a cotangent? What might I do? Yeah, so you want to change cosecant squared. It's hard to change a cotangent by itself into a cosecant, but it's easy to change a cosecant squared into a cotangent. So using the identity that cotangent squared plus 1 is equal to cosecant squared, I'm going to plug in cotangent squared plus 1. Whoops, don't forget your x's. Doesn't mean anything without the x. Okay, minus cotangent of x minus 3. And then I'm going to combine my like terms. I have a 1 and a minus 3. So I could rewrite this as cotangent squared x minus cotangent x minus 2. Right? And this is just as if I have, pretend they're x's, then they'll be more friendly. X squared minus x minus 2. Could you factor x squared minus x minus 2?
No.
Then you could factor cotangent squared minus cotangent x minus 2. Right? And the way you do that is you go, so this would be what? How would I factor that? Yeah, minus 2 plus 1. So when I factor this, same thing, I just do cotangent of x minus 2 times cotangent of x plus 1. And I think this is a really nice chapter because usually in the old books that we used to use, they would just jump into solving trig equations and they expect you know how to do all this stuff. So this is kind of giving you tools that you're going to be using to solving trig equations, okay? So like sometimes they'll say, okay, this is equal to 0, and they'll solve that trig equation. And that's why they're setting you up to do all this stuff, all right? So it's kind of a nice preview section. What if I saw this and they said simplify? Simplify sine of t plus cotangent of t. So that means cotangent of t like that, not cotangent of t times t. And it doesn't mean cotangent times t, it means cotangent of t. Cosine of t. Anyone have an idea of how to simplify that? They say simplify. Derek Wright knows. Go ahead.
So I would make cotangent of t cosine.
Very nice. Okay. So he's going to use some of the he's using the quotient identity, and that a lot of times, if you have things with cotangents mixed in sines and stuff, you want to change everything into sines and cosines. All right. Now what? Go ahead, Derek. Tell me what to do next. You can't cancel anything yet.
Or you can multiply cosine t times cosine t.
Okay. Yeah, you can multiply that together. But before let's do that. Okay, we'll take one step at a time. Sine t plus cosine squared of t over, and they want it without no fractions. No fracking. Fracking. All right. So you don't want any fractions. They had a ballot on they had an issue on the ballot about no fractions, didn't they? Oh, there was no fracking. Oh, sorry, I got confused. All right. So that. I'm sorry. There was no fractions. No fraction. Okay, so cosine squared over sine of t. Okay. Now that's a sine. So how could I get no fractions? Let's try something. Could I find? Who sees something else I could do that's looking kind of like make it? Go ahead.
Is it sine squared t plus cosine squared t?
Yes, you're getting there. But how would I turn this into a sine squared t?
So I would just multiply
Right?
sine.
I have to multiply this by sine of t over sine of t, right? So you get sine squared of t plus cosine squared of t
Equals 1.
over, yeah, that's equal 1, but that's still over the common denominator, right? You have a denominator here, which is sine of t.
Cosine squared.
Oh, cosine squared here. And you guys know that identity is 1 over sine of t. How do I change that so there's no fractions? What's that equal to? Cosecant t. Okay? Cosecant t, and we're done. Okay? You follow that? So that's kind of a good little trick. Mr. Beamer made up a really good math joke. He said, why do trigonometry students not make very good, I forgot what it was, very good weather people? Because they think that this is a composite function. Something like that. I don't know. Okay. But okay. So anyway, so there's that, and then that was pretty bad. I know.
Your joke's better.
My jokes are bad. So we have one more example, and then something weird called trig substitution, which is kind of a calculus topic, but we're just going to just stick in one problem like this. So what if they say this? Rewrite with no fractions. Again, rewrite with no frackings. Rewrite, I'm almost done, guys, without fractions. So this is kind of like what you did when you had eyes, and you're trying to get rid of the eyes. How did I get rid of the eyes? Multiplied by the conjugate, okay? So that's what you do here. You multiply the top and the bottom by the conjugate of the bottom. So I'm going to multiply by 1 minus sine of x. And most times, that's going to make things disappear, you see? So what I do is I FOIL this. On the top, I just have my 1 minus sine of x, right? But then on the bottom, I have 1, what do I have? I want to make sure I'm doing this right. That turns into 1 minus sine squared of x. What is this? I don't need that, okay? Because when I multiply that together, I just get 1 minus sine x. And on the bottom, I get 1 minus sine squared of x. Does anyone not see where I get 1 minus sine squared of x from? Okay, what's 1 minus sine squared of x equal to? Here, cosine squared of x. So now I could rewrite this as 1 minus sine of x over cos squared x, and then they break this into 2 different pieces because you're trying to write it without any correction. So you know, like you could write 2 minus 3 over 5 as 2 over 5 minus 3 over 5, right? Could I do that? So I could write this as 1 over cosine squared x minus sine of x, and instead of writing this as cosine squared x, I'm going to write it as cosine x times cosine x. Why would I do that? What's this equal to? That's equal to secant squared x, okay? And this is equal to what sine over cosine? Tangent x. And it's kind of like understood that there's kind of a 1 here, right? What's 1 over cosine x? Secant x. And so now I have written this expression, 1 minus sine of x, as an equivalent expression without any fractions in it. That's kind of tricky. But when you get to trig identities, you're going to have to use all of these techniques to solve trig identities. All right? Did you follow that? Okay. Last thing is called trig substitution, and you use this. You use this in calculus, and they like to throw in, or Mr. Beamer and I think it's a good idea when you get to calculus, you have some exposure to this. So use the substitution And this is just applying trig again. Substitution x equals 2 tan of theta. 2 tan of theta. To write square root of 4 plus x squared as a trig function. Last thing, trig function of theta. Okay? And why would you ever want to do something stupid like this? It's because when you get to calculus, they have something called integrals. Okay? And integrals are they're functions, and you're trying to find the area under a function or the volume of something using integration techniques, or the work done by using integration techniques. And sometimes you use something called trig substitution, right? And so we're kind of setting you up to know the methodology they use to do it. So all you have to do is take this and plug it in. They tell you, or you have to, when you get to calculus, you'll figure out what to plug in. But at this point, we're just going to tell you what to plug in. So this is going to be equal to 4 plus 2 tan of theta quantity squared. All right? And this is a little tricky. Now I'm going to do some stuff on it. Okay? This is equal to 4 plus what? How could I rewrite this? 4 tan squared theta. Do you see something that is in both of these guys right here? I have a 4. So what I'm going to do is I'm going to factor out of 4 out of both these 1 plus tan squared of theta. Okay? And you get out, what's 1 plus tan squared of theta equal to? Look up here. What's 1 plus tan squared of theta? Secant squared of theta. So I have 4 times the secant squared of theta. What's the square root of 4?
2.
What's the square root of secant squared? 2 secant theta. Okay? And so this would be your final answer. Why would you ever want to do that? Because if you're doing something like this, called an integral, okay? If you're taking the integral of that, which you will do when you get to calculus, it's kind of impossible to take the integral of this. But taking the integral of this is pretty easy to do. Okay? So that's why they teach you how to do it, because there's just a formula for finding the integral of secant, but there's no formula for finding the integral of 4 plus square root of 4 plus x squared. And so they're kind of setting you up to prepare you for calculus. That's why it's called pre-calculus, right? So your homework, which you're going to do over this long 3-day weekend, right?
Maybe.
Yes, is, what time do we get out again? This is period 5. So we get out at 12. So I had time to bring up the assignment here, which I'm going to do for those viewers who are not here. Who's not here today? No one's not here. Is anyone not here? Index. Pre-calc assignments, as you can see, I now have a chapter 5 page, which is not very updated yet. But whoops. So you can see that homework. Whoops. Where did it go? Where did it go? I wanted to copy that. Okay, let me try that again. It was in here, right? No, it's here.
No, keep going over
Here.
that one, yeah.
That one. There it is. So, I could cut. You could see that, right? Page 354, 1 through 6.
I can see it.
Can I what? Blow it up?
On this page.
I might get in trouble for doing this.
No, I know, I'm just saying.
There you go. Blow it up. There you go. Where'd it go? There it is. I'm blowing it up. Now I can hit pause and